right, I'm going to share my screen and then I'm going to go open up my other laptop and see, because I don't know if I can do the Facebook live stuff from my phone.
You had trouble with that once before?
I'm sharing the post right now, at least to my people.
So they can hear us?
Hey, Dennis or Mike, can somebody post onto the forum?
Okay, you can come back.
Mike, how about you post on the forum, Mike?
I can't from this. I'm outside. I only have the one laptop. I'll have to jump screens and stuff. But let me give this a shot. Might be able to get over there really quickly.
Okay, I've sent the link out.
Yes, I
I
did.
do hear
Wait a
some
minute, you have the link?
background noise.
Did you send the link to us, or where did the link go?
Yeah, it's gone to your email and also in the chat.
Okay.
Let me know and I'll get onto my Facebook.
There's a link.
How did I lose that?
Why the hell? Oh, caps locks.
Yeah.
Geez, I'm like, why can't I log in?
Yeah, the link is. I can't zoom in on it.
No, I mean, where's the link?
It's that.
Oh, good Lord. I'm just gonna do a search. Oh, Facebook. I'm already on Facebook, so I don't need all that other crap. Read off the numbers to me.
2276 219 50719 757
That's it.
slash.
Oh.
Hold on.
Ernie, do you have a spot on the forums where you want it?
There should be the last post I made is the post that we've been using. It's like Tuesday, Monday is Tuesday.
Let's see. Okay, let's see. We just need to.
Well, ladies and gentlemen, we're alive. We're excited. We have 30 viewers already.
Wow.
Ooh.
It's outstanding.
They might
Let me
just burn
reposition the moon.
Yeah, yeah.
So we're doing our social media and
Yeah,
everybody's still connecting here. So
Oh, that's
not
cool.
on Facebook. So is this it?
Yep. About as
and the
fast
moon
as
will
it
get better as it gets darker. So we still have the sun up, which is washing out the view.
Yep. It's about as high def as you can get of the moon. I mean, that's
So is this your teachers doing this?
no. Somebody from.
Okay, I put up a thing on the website on the post. I said, good seeing, we are live, and I posted the link to the YouTube.
Thanks,
But
Ed.
it didn't post the link. I'm not sure why. Oh, there it is. Okay, so it is doing live on the website too. Pretty cool. Hey, I didn't know our website could do that. The BAA website, if you're a member, you can log in and under our forums, Tuesday will be Monday night. We posted a link to this live event and it's actually broadcasting live right on our website too.
Ooh, excellent. Thanks, Dennis.
Okay.
What do you say, everybody? Do we want to
I'm
officially
going live to
start?
the PAA page too.
Hey, Holly, I think we could probably introduce ourselves and maybe get a little started.
All right, sounds good. Great. So we will officially begin. Welcome everybody to our first, I guess, official installment of Looking Up. This is sort of like a virtual star party hosted by myself and a few of my friends and colleagues. So I believe we may as well just do some introductions, just so you guys know voices and faces. So my name is Holly Cohen. I am a member of the Buffalo Astronomical Association and a pretty avid astronomer myself. Still learning. Most of the people who join us tonight are actually the people that I have been learning from this entire time. We've got quite a nice wealth of experts here from the Buffalo Astronomical Association and from affiliated institutions, including Penn Dixie Fossil Park and Nature Reserve, one of my favorite places. So let's see. Today we are joined by we have, if you guys just want to maybe like wave your hands or anything, we've got Adam Hansen here.
Hello.
Say hi.
So
Hello, everyone.
Adam is a BAA member and a Penn Dixie volunteer astronomer. He works with the Fossil Park often with their astronomy nights. Also with us is Jim Maroney. Is he around? Still waiting on Jim? I believe so. Well, he may be joining us later on. We are also joined by Ernie Jacobs. Ernie, if you want to wave.
Hello. Hello, everyone.
Ernie is also an astronomer, a volunteer astronomer for Penn Dixie. He is also a Buffalo Astronomical Association board member. And I'm actually going to refer to BAA because that's quite a mouthful for me. So also with us is Dennis Bartkowiak. Dennis, if you want to,
Hey, everybody.
you want to wave with the funky moon background. Dennis is the vice president of the BAA. We are also joined by BAA president Mike Humphrey.
Hey, everybody.
And of course, the executive director of Penn Dixie, Dr. Phil Stokes.
Good evening. Thank you for joining us. I'm really excited to have so many people that are excited to join our program. This is our first time with clear skies and can't wait to see some planets and stars.
Yeah, so if you are joining us for the first time here, all of us are kind of doing this just because it's a really weird time right now. We'd like to offer some sort of diversion to get a little bit more back to normal, at least in the sense of hopefully learning something every day. All of us here have a passion for learning and a passion for astronomy, and we don't see any reason that needs to stop. So if you want to join us, stay tuned. If you want to ask us some questions, I'll be monitoring the chat and we'll try to answer as many as we can. Do we have anybody who would like to start?
I can go till somebody else is ready.
I'm for that.
Okay. All right. I'll bring up the moon.
Take it away, Ernie.
All right. So this is a very washed out view of the moon. Unfortunately, the sun is still up. So once the sun goes down, the view should dramatically improve. The large dark region that you see here is Mare Crisium, Sea of Crisis. This crater here, I believe, is Cleomedes. I'm probably butchering the pronunciation because I cannot pronounce anything. But this is a live view through an 8-inch reflecting telescope. And my telescope normally does not track. So you notice that every once in a while I have to get up and move my telescope because I have it on a little platform that is helping to keep it in place. And we have a camera on it that's hooked up to the computer. And that's the screen that I'm sharing right now that you see. That's the capture software. And this is a live view of the moon. Or as it was 1.055 milliseconds ago. I don't know if anybody, does anybody have, anybody want to take us through any more of the craters or?
All right, I have a question.
Sure.
In your view of the moon that you have right now showing to us, can you point out any of the other seas?
They're a little washed out right now. But Mare Tranquillitatis and Mare, I'm not even going to try this one, Fecunditis. Anybody can help me out there?
Yeah.
Are down below. I can move my view a little bit. I think the scope isn't on a mount. It's a little hard. Move. You want it. What I wanted. So this region right here is, and I actually don't know what this one stands for, but it's Mare. Oops, computer thought I was going to change the region of interest. That would have been bad. Mare fecunditis. Fecunditatis, maybe. Not, like I said, very good with better with the telescope than I am with the Latin.
As we all are.
This is Mare Nectaris right here. I'll move down a little further. So now we're looking closer to the South Pole, which is a heavily cratered region of the moon. Anybody checking Facebook comments, see if we have any questions?
Yep, we've just a lot of people saying cool, and I agree.
Yeah.
Hello?
Increased. Hello.
Yeah, just checking things out over here.
Hey, Dan.
Yeah, I just have to see how to get my video on.
Hey, there he is.
We also
Okay.
have now joining us Dan Marcus, who's observatory director and head of the Tuesday night imaging group.
Right. Roast needed a haircut.
Aren't we all? Here, Dan, to match the name to the face, can you just give us a quick wave? There he is.
One with the hairdo.
That's
Ooh.
not a hairdo, this is.
I'm getting a question on Facebook From Joanne Feldman Frank. She actually has a question that one of her kids has been asking. That is, how do nebulas form? Does anyone want to take a stab at it, or should I go right for it?
Go for it.
All
Go
right.
for it.
So nebulas, or you can also say nebulae, they're, in case you haven't learned about these before, they're kind of these gas and cloud clumps, basically just clouds of all this cosmic gas and dust floating around out in space. These things are hundreds or thousands of light years across. They're much larger than the solar system. And most of the time, I would say these are actually places where we can find new stars being born. I'm actually sitting in front of one right here. That is a Hubble image of what's called the Bubble Nebula from the Hubble Space Telescope, which just celebrated its 30th birthday. Very colorful, very strange objects. Now, how do they form? There can actually be a lot of reasons that these things kind of come into existence, and a lot of the ways that you get these nebulae are kind of violent. So imagine you have a star that is much larger and more massive and heavier and kind of more powerful than our own sun. Our sun is kind of a medium-sized star. Now imagine you have a very large star right at the end of its life. The way that these stars pass away when they're all finished and they're out of their fuel, they will sometimes collapse in on themselves and explode in a supernova. Now, all of that gas that was kind of taking up the mass of the large star kind of has nowhere to go but out with the explosion. So it's actually going to blast out a lot of that gas that was kind of causing the star to burn and causing the star to create fuel. Now, this is happening so quickly and so violently that some of the atoms in that gas will actually smash together and create new materials, new elements, things that you'd see on the periodic table. And with all of that, you'll actually get new stuff made out of total destruction, total explosions. So you can get nebulae from dying stars. You can also get them it's kind of strange. A lot of those materials that you find in nebulae do come from dying stars, but help me out, guys. There's another way for nebulae to form that is
There's
escaping
also
me right now.
planetary. There's also
Planetary.
planetary nebula.
Thank you.
Which would be how our star is going to die. But I
Exactly.
just wanted to interject one thing real quick, Holly.
Yeah.
So your comment about the elements, and you've probably heard the We Are Star stuff. I was just listening to a podcast, and one of the scientists who was critical in making that determination was a female scientist. Her name was Margaret Burbridge, and she just recently passed away. And her spectroscopic data was the critical data in a very important paper almost 50 years ago that led us to that conclusion. And she just very recently passed away, like within the last several weeks.
Oh.
And she has quite an amazing story, but go ahead.
No, that's great. I'd love to see. I'm learning more every day when we do this here. No, I'd really love to hear about my fellow lady astronomers. So yes, what Ernie was referring to for kind of the other type of nebula. They're called planetary nebulas, which may cause you to think that they're made from planets. Not so. If you have a star like our sun, or actually our sun, and in a couple of billion years, you don't have to worry about it now, as that kind of medium-sized star will start to run out of its fuel and kind of start to die, it will swell in size. It will get larger in size, and it will actually throw off layers of gas that used to belong to the star. And eventually, as that star continues to die, it will start to shrink down into a cooler, less powerful, less massive star. They're called planetary nebulas because a long time ago, before we had really good telescopes, that kind of round shape, similar to what you see behind me, were kind of mistaken for other planets by people who did not have the amazing astronomy knowledge that we do as humankind does now, or just people who don't have telescopes. We've got a couple of more questions here, unless anyone else would like to interject.
Go ahead.
That was pretty good.
Oh, thanks. Actually, I may ask one of our BAA members to bring up a resource that we were looking at last time. We have a question here. Can you locate former like Apollo, I guess like mission leftovers, left material from the Apollo missions on the surface of the moon? And my short answer would be yes. We have an orbiter currently going around the moon called the Lunar Reconnaissance Orbiter. It takes very nice high definition pictures. And we can actually get such high def pictures that you can kind of zoom in a little bit and see a reflective spot that represents the lower descent stage of all of these Apollo spacecraft. You know, you had to land down on the moon safely, and then when the Apollo astronauts went back to the command module going around the moon, they had to lift off and leave that landing gear down there. You can find that landing gear, and in some cases you can even actually see tracks of the footprints of the astronauts. So if anybody can find those images, we can certainly visit those.
Well, while you're talking, I'm kind of looking that up now, bring it up on my computer. But as I'm looking, I can let you know, NASA's released a resource. It's called Moon Trek, and it's the LRO images. And when you go there, it's got the ability, you can type in Apollo 11, and you can go right to the surface and take a look, and you can see the landing, you can see footprints going around, you can see the reflector. So just a little bit later, while somebody else is talking, I'm going to bring up that resource, and then we'll flash it across the screen so everybody can get a look. So we can get a look at we can look at all the Apollo missions and some of the other stuff that's down there. Plus, if you go there, you can take some flights around, some other kinds of things. So it's actually pretty decent. And it's called
fun.
Moon Trek.
Moon
But,
Trek.
I'm sorry.
Pulled up the space.com website on the Apollo 11 LRO image. If you want, I can share it.
Okay.
Okay.
Real quick, if everybody can see where my cursor is right now, that's approximately where the Apollo 17 landing site was. So
I'll have to look up Apollo 17 then. Oh, there's the flag
There
on the
you
moon.
Ha, there's
You
the
won't
flag
see
on
the
the
flag
moon.
on the
Good
moon.
one, Dennis.
let me know
You
when
can't
you're
see
ready
the flag on the
to
moon,
stop sharing.
except for this picture right here. That's, you know. Okay, so I'm gonna go ahead and I'm gonna, let's see, I gotta try this share the screen part. And I'm gonna pull this up. And let's see, sharing. Okay, so now I'm sharing, this is the Google website. And on this Google website, you can see in unprecedented detail the Apollo 11 landing site. And you can see the reflections like Holly was talking about, and you can even see some of the trails where the astronauts walk. And it points out, but that's the most detail that we're gonna get when we look at the moon from a satellite literally orbiting and imaging the moon. From the Earth, now we're not going to be able to see it. It's just too far away.
Now, interesting that you mentioned that, Dennis, because there is one kind of piece of equipment that we did leave on the moon that we can access from Earth. You just have to know exactly where to look. There's, I think it's called the Lunar Mirror Array or something in that neighborhood. And it's actually a set of mirrors that one of the Apollo crews, if anyone knows, just jump in, actually left on the surface of the moon. And what some observatories down here on the ground on Earth can do is they can shine a laser right at that set of mirrors and actually measure how long it takes for that light to kind of come back to us. So it is the most precise way to measure how far away the moon is from us at any one time. Now, of course, we can't see that with our own eyes. You have to belong to a very advanced coalition of astronomers for that.
So the technology was originated at MIT in 1962. They applied this. It's called a retroreflector. It's basically the same kind of material that you'll find laminated on your stop signs, your roadway signs, and even your roadway paints too. It just allows the light to scatter back to you. The first retroreflector array was placed on July 21st, 1969 by the crew of Apollo 11, and two more retroreflector arrays were left by the crews of Apollo 14 and Apollo 15 as well.
And that actually brings up another interesting point too. And what Ern was talking about earlier, it takes about 1.2 seconds for light from the moon to get to the Earth. And when you start looking at that, you start looking at speed limits. For instance, the sun is 93 million miles away. It takes 8 minutes for light from the sun to get here. Now, if you're looking at some other kind of speed limits, it takes about 3 minutes for light from Mars to get here, about 54 minutes from light from Jupiter to get here, and about 78 minutes from light reflected off of Saturn to get here. So when you go outside and you're taking a look at the planets, when you look at the moon, you're looking at the moon like it was 1.2 seconds ago. But when you look at the sun, that's 8 minutes. And if you think about it, if you find Jupiter, and this is an experiment that you can do, go out, find Jupiter, take a look at it and look where you're pointing, and then go out an hour later, and where you see it, that's where it was when you were looking at it. It's kind of heady kinds of things, but we like this kind of stuff.
Yeah, and the great part about light is the speed of it is constant for the most part, and that's how we're able to use it as a tool. We know how long it takes to get from point A to point B. So if we point it to the moon, we know when we let our laser light leave Earth and calculate the time it takes for the signal to get back, and that's how we can accurately figure out the distance. And that distance varies by the eccentricities of the moon's orbit.
Correct.
Because of that constant, we're able to figure out that there is an eccentric orbit to the moon too.
I saw a question on the chat about somebody had a question about why the moon rises and sets at different times every day. Did anybody want to take that?
So
I always jumble up my words, so
moon-
somebody else take this one away.
So the moon is orbiting the Earth. The sun is the center of our galaxy. We are the center of our solar system. I'm sorry. The sun is the center of our solar system. We are the center of the moon's lunar system, if you want to call it that. And because it's rotating, it's orbiting around the Earth once every 27.3 days or so. It's going to be like shining a flashlight at your hand. And as it moves around, you're going to see different parts of that same surface, but the light's going to cast differently as it moves around.
And there's another factor, and that's true. And there's another factor that's involved. The Earth itself is not. When you see pictures of it, it looks like we're rotating around the sun on a flat angle, but we're not. We're actually tilted. I think it's like 28 degrees. The moon is tilted in its orbit around the Earth, and because of those two tilts, that's why the moon rises and sets. What it looks like is still going from east to west, but it looks like it's rising at different times and setting, but it looks like it's setting in different places. But it's actually because of the plane of the orbits.
Interesting. I really thought, I was thinking, just more asking why it rises and sets at different times. Well, when it's new, it has to rise with the sun and set with the sun. And since its orbit, it depends on where it is in its orbit. When it's new, it's next to the sun. And when it's full, it's opposite the sun. So it rises when the sun sets. So, and all the phases are rest around in between. So I assume that's what he's asking. It's really due to the fact that the moon is orbiting the Earth. And since it doesn't orbit the Earth once a day, it orbits the Earth every, say, 27 point something days or whatever it is. Forget. But since it doesn't do a complete circle in one day, it's going to rise and set. And you'll watch it move in the night sky. It'll move to the left because it runs a little slow.
Does anybody? I can see Venus.
Yeah, I got Venus on the screen.
You do? You want to share?
Yeah, I'll have it. Should be able to do that.
All right, so
Share screen. Here we go.
transitioning over to Venus.
Let me stop.
You all right? Try that. Let's see. Come on. Sure. There we go. There's Venus.
Oh wow, look at that.
Yeah, I was watching it today in the daytime.
So let me ask, for anybody who is a little bit new to this, is there a reason that Venus is looking the exact same shape as the moon?
Coincidence. If you come out when the moon is full, Venus will still be in a crescent phase. Venus depends on where it is in its orbit with relation to us. When it's on the opposite side of the sun from us, exactly opposite, where the sun covered up, you see a full Venus, and it's a lot smaller because it's a Venus orbit plus an Earth orbit away. And when Venus comes between the Earth and the sun, then Venus gets much bigger, but it becomes a thin crescent, just like it becomes a new moon. When you really have a new moon Venus, it's when you get a Venus transit, which we had several years back. So right now, I forget whether I'm pretty sure it's thinning. So it's in the process of passing in front of the sun, or at least above or below the sun. If it passed in front of the sun, we'd all be waiting for it.
It's getting bigger. It's getting bigger and thinner. So, yeah.
Correct. So that means it's heading towards Earth. And what happens is now it's going to be the distance between the Earth and Venus. When it passes between the two of us, we take Venus's orbit distance from the sun. We take that distance, and we take the Earth's distance to the sun. You can subtract the two, and that gives you the distance between Earth and Venus. And when it's on the other side of the sun, when it's smaller, you take Venus orbit and add it to the Earth's orbit to get the distance. So that's why it gets a lot smaller when it gets full.
So we can actually get kind of crescent, gibbous, new, full, all of these phases from Venus.
Correct.
And anything else between the Earth and the sun, am I correct?
That's correct.
All right.
The
So
hard part is to see Venus when it's full, because it's not very bright since it's very far away. When the sun is blindingly bright, you really can't see it. I've seen the crescent Venus like 3 days before Venus transit. So you can see the crescent phase fairly well because it's pretty big and bright. But when it's a little small, tiny, faint dot, it's very hard to see.
Very cool. I've got
This is
a
a
couple
question
more.
I have.
Oh, sorry. Go
My
ahead.
fellow, for my fellow BAA members. So a couple months ago, there was the transit of Mercury in front of the sun, as it was between us and the sun. Can that happen with Venus as well?
Yes.
Is it the plane the same?
Yeah, the problem is you won't see it for another 100 years.
Well, the last one was in 2012, and it did it. What was it? 2004, 2006? How many
Yes,
years?
somewhere in there.
Yeah.
Probably
I believe
2004.
2008.
Okay. And in 2012 was the last one, right?
Right. And I think it's like it goes in 100-year cycles. It's like 100 and some odd and 110 thereabouts. It's a strange arrangement, but it does two in quick succession, then you wait 100 years plus, and you see another two in quick succession. So if you're real lucky, you get to see
Like
two.
14. Yeah, you see the first one, then it's 14 years to the next one, and then that's it till the next 100.
Yeah.
Now, luckily, with Mercury transiting the sun, it's a little bit more frequent.
Yes.
We just had our last one on Veterans Day, I believe. It was either November 11th, maybe November 12th.
Yep.
It was a little bit cloudy here, so we couldn't see it too well. But the next one that will be visible, at least from Buffalo, is somewhere in the order of about 30 years away.
Yeah, I think so.
So yeah, we'll all be older, but it's possible. I've got a couple more questions, unless anybody else here on our chat would like to show off what you're looking at.
No, go ahead. Rip off.
All right. So we'll answer a few more questions.
Okay. I'm gonna stop the share on Venus.
Sure.
Let someone else take the screen.
This is a fun question, I would agree. So Ronald has actually asked the question, do we know how many galaxies there are? That's a very huge question. I don't know how many we have actually really cataloged. We've got, an astronomical number of them, so to speak. Looks like Ernie really wants to get in on it, though.
I think Des knows they recently revised the estimate upwards to like 2.2 trillion.
2.2 trillion.
Yes, and I think
Wow.
a lot of that is based on some of the deep sky, the deep field images from Hubble. So they and other surveys they've been doing, but they've revised that number upwards. So if you can imagine, 2.2 trillion galaxies with billions of stars in each galaxy with planets around each star. The numbers are just absolutely mind-boggling.
And if you also add in that that's what's called observable universe, so it's based on mathematical calculations, radio observations, light observations, a lot of different things, but we know that there's stuff beyond what we can actually observe. So, I mean, that's all we can say, that this is what we can definitely say is here, but we know that there's stuff beyond that.
Yes, when you count all those billions of stars inside trillions of galaxies, the old saying is that there are more stars than there are grains of sand on all the beaches, all over the world, at the bottom of the ocean, and everything else. I would like to say it's hard to wrap your mind around it, but I'm pretty sure you just can't. It's a big universe out there.
The numbers are truly astronomical.
When you learn about this stuff over and over again, you kind of get reminded how small just one person or one planet or even one solar system is. A lot of my fellow astronomers in college would just call it the cosmic perspective. You just get to look up and see everything else going on around you. Quite peaceful.
Dennis, you've got a lovely view of the moon up. Maybe you could tell us a little bit about how you're, what equipment you're using to get this image.
Well, I'm using a 80 millimeter refractor with a ZWO ASI 071 Pro. It's a dedicated deep sky camera. It's a color camera. So the reason that you're seeing it in kind of that bluish tint is I actually have a light pollution filter on the camera at the moment. That helps dim some of the light and get certain light reflections too. It's kind of on a mount that's tracking. I'm sitting inside where it's nice and warm. I'm our observatory director. So it's sitting outside my house now and just pointed at the moon and tracking. So what you're seeing is a live image from that camera attached to my mount. The camera is kind of turned a little bit sideways, so that's why you see the picture in a different orientation than Ernie is. I can zoom in a little bit on it, but once I zoom in, I lose some of that detail. One of the reasons I do that is that because this is a picture of the moon. So when you look at the moon, this is 100%. That's as close as I'm going to get with this camera attached. So it's on a mount that's tracking it. It's an EQ6 mount from Skywatcher, and it's tracking pretty well. I didn't get the polar align. What I mean by polar align is get my scope lined up with the North Pole so that it tracks everything perfectly. So you'll see this image drift just faintly as we do, as you're watching it. One of the reasons that you see moments of clarity is also our skies, the stuff that you're seeing as it gets a little bit darker, but also our atmosphere is a little turbulent. So you'll see good and bad stuff come out. And so normally when I image things and image stuff like the moon, I actually set this camera up to record video. And you take lots and lots of pictures on the video and then combine some of those best pictures to get a good image. That's kind of something we might be doing a little later on or at our next thing, our next looking up. But for now, focused on the moon, and I can adjust it as it gets a little bit darker here. The image gets a little bit better. Well, that's kind of what I'm doing here.
Anybody else have anything up?
I'll stop
It's a little bright out.
What do you have? Someone asked if we could see Jupiter right now. And the answer to that question is not till after about 1:30 in the morning. So if you get up between about 1:30 in the morning and before the sun rises, you can see what we call the morning planets. And for the next month or two, they're gonna be just that, the morning planets. Jupiter will be the highest and the brightest, followed by Saturn, which is fairly close by, a little bit closer, a little bit further east, and but pretty close to Jupiter. And then Mars is closer to the horizon. And then in a few weeks, about mid-month, the moon will join the party, and they'll all be in a nice line over the course of a few days, the moon will move from being close to Jupiter, down to being close to Mars, and finally, it'll be heading towards new. So I could bring up Stellarium real quick and do a quick sky tour.
Yeah, do a quick
Okay,
sky
do
tour.
that.
That'll give
Yeah,
us
it's nice.
to look at and show us people what they can see and how they can see it show up where they are.
You know what, Ernie, why don't you go to say 9 o'clock in
Good night.
Stellarium?
Oh, okay, yeah. So it's lighter
Yeah.
or darker? Yeah.
Yeah, so it'll be darker. So when people, when we're done, if you want to go outside, here's the stuff that you'll be able to see, say 9-ish or so.
A little too fast. Okay, so I'm gonna go back to, hang on. I'm gonna go back to Zoom and I'm gonna share my screen. Just bear with me. All right, and now I'm gonna make this. Are you guys seeing Stellarium?
Yep,
That
I see it.
Okay. Hang on, it's gonna open up a second time because I clicked the wrong button.
So for those of you who are not familiar with Stellarium, this is actually a free, I suppose, open source planetarium software. So you can actually get this for free on your own computer, and it's quite a nice tool. If it's a clear night outside, you can plug in where you are and when you are, and you'll be able to see things like what you've got on your screen here. You'll be able to see the constellations, the planets, and the kind of the views of the moon of really any day and time.
And it's multi-platform. So if you have Apple, if you have Android, you have PC, if you have Linux, it'll work on all of those platforms. And they just recently updated it, which is 20.1. It's very good.
Yep. So we're looking west right now in about a half an hour or so, about 8:45. And you can see in the west, the moon and Venus will be setting in the west. And I'll turn on the constellation lines. And you can see that the moon right now is in the bottom of the constellation Gemini, the twins. And the one star here on the right, called Castor, if anyone out there is 51 years old, that star is 51 light years away. So the light coming from that star left about when you were born and is getting here now. And that'll be setting as it gets dark. That'll be getting closer to the western horizon. And let's see here. Betelgeuse is the bright shoulder of Orion, the constellation Orion. The Hunter, which is setting, it's a winter constellation. As we start to progress through spring towards summer, we are going to lose it till next season. And unfortunately, it's not going supernova. So at least it will go supernova, but everybody was thinking that it was dimming and that might be a sign, and it's not. And just off the horizon, you can see the star Sirius, the bright star Sirius, the brightest star in our night sky. It's, I believe, it's fairly close, about 8 light years away. And it's actually a double star. And with the correct equipment, you can actually split Sirius A from its very small partner, Sirius B. I don't know if anybody in the astronomy club has ever done that. And then if I scooch over to the east, we have our constellations of summer starting to rise. We have Hercules, you have Corona Borealis, here I can turn the names on. Corona Borealis here, high in the east. The constellation Hercules, which is easily recognizable by the prominent keystone pattern. And if you have a pair of binoculars, right about here where I have my mouse tip, there's what look like a fuzzy star. And it's actually what we call a globular cluster, M13. It's about 100,000 to 300,000 or so stars gravitationally bound together. And we have our summer triangle starting to rise. And I'll start to move the clock forward a little bit. And then you can see here we have the summer triangle has risen. The bright star Vega in the constellation Lyra the Harp, Deneb, which is the tail of Cygnus the Swan, or the end of the Northern Cross asterism, and Altair in Aquila the Eagle, which was Zeus's eagle. It used to carry Zeus's lightning bolts. And unfortunately, I hit the wrong button. So we're back to now. Let me quickly. So I moved the time forward. And as you can see, we're at 2:30 in the morning, and we have all of the morning planets up by now. And you can see that they form a line in the sky, and that what they're actually tracing out, the line that they're tracing out is the plane of our galaxy, which we call the ecliptic. And when the moon joins them, the moon and the sun travels that plane. So that plane would roughly look something like the way that I'm moving my cursor across the screen. It would go and come back down in the west. As you noticed here in the south, there's a constellation called Sagittarius, the Archer. And within that constellation, there's actually a very recognizable pattern, which we call an asterism, of the teapot. This is the spot of the teapot, this is the top, and this is the handle of the teapot. And in reasonably dark skies, this constellation is asterism is very recognizable. And what's kind of remarkable is that if you're in dark enough skies that you can see the Milky Way will appear to rise as steam out of the spout of the teapot. And in fact, not far from the tip of that spout is where the center of our galaxy is, about 27,000 light years, where there's a supermassive black hole about 4 million times the mass of our sun, upon which everything in the galaxy is rotating. So I think that's it for our Stellarium Night Sky Tour, unless anybody has any specific questions that they see on the chat. Going once. Okay, I'll stop my share and see where my telescope's pointing.
So Ernie, I actually have, well, and everybody, I have a few questions queued up, a little bit more about our moon, if we want to kind of head back briefly and revisit a little bit more of our moon theme.
Right. Mind if I share my view of the moon, or?
Go for it.
Does somebody else, by the way, does anybody else have anything up?
Yeah, if anyone wants to share.
I have a cool little program that is also free for people who just want to sit at their computer and explore. It's Google Earth. It's the actual program, not when you just type in Google Maps, but you have to go to the Google website, type in Google Earth Pro, and you can download the app. And I'll share the screen here. And there's a lot of cool other tools. Like everyone's familiar with Google Earth, right? You can see your house, you can see your neighbor's house, you can see all the way on the other side of the world. This kind of does the same thing with not only moon, it does it with Mars. So once you open up the program, you'll see your normal planet of the Earth. And you can come up here to the top, and you can also, oh, sky, that's what it was. You can view the night sky. So let's choose moon here. It'll load up the moon. And it'll bring us to the side of the moon that we can see, that's tidally locked to the Earth. We always see this side of the moon. If you come down here on the left, there's some galleries, some guided tours. So let's just pick Apollo 11. We'll zoom in and explore this landing site. So Apollo 11 was man's first landing on the moon. Buzz Aldrin, Neil Armstrong. Neil Armstrong was the first on the moon. Buzz walked down minutes later as the second, while Michael Collins was up in the service module, maintaining the service module, maintaining communications, performing other services for the astronauts down on the ground. So here, this I believe is another one of those LRO, Lunar Reconnaissance Orbiter images with superimposed our lander down on the bottom with the attached descent module. And you can kind of see the path of where the astronauts kind of walked around by these dark areas, these dark lines where their feet actually undulated the surface. They kicked up these newer materials that weren't bleached out by the sun. You can also, oh, that was probably not the right thing to click. Oh, it's a panorama. I was going to show like they uploaded certain images. Okay, we can zoom in, and they know about where these images were taken. This program was highly documented. It's not going to let me load it, but that's one cool tool that you can use. It's free, available out there. You could also do Mars for just, giggles. It also has a similar kind of features where you can come down here, Traveler's Guide to Mars, rovers and landers. That's a fun one. You can see where the Curiosity here. We'll zoom us into the site, show you the path of where it's traveled. Again, you can click on some of the links here. Some of them will be a little bit more detailed information. Some will be pictures. I thought this was a really, really fun, easy little program that you can use. Very robust too. I mean, let's try skies, see how accurate this is. I haven't played around with it yet.
Hey, Dan,
Yeah.
do you have a good lunar atlas or anything?
Well, I have my old Norton Star Atlas that will show those craters.
I was wondering I could pull the moon back up, and maybe
I
somebody
can't pronounce things, so you're.
can't do any worse than I did.
Oh, I got
You
news for you.
should have heard me try to do the one that begins with F.
I'll bet. 1 second here. I was just going to finish off a solar image. See if it works. Come on, there it goes.
Bring up the moon, the north pole of the moon. Being a good Greek, I can pronounce these two craters no problem. But this one's Atlas and this one's Hercules. So, or Heracles, depending on how you pronounce.
So Ernie, we actually received a question a couple minutes ago asking how craters are formed. Would you like to speak to that as we look at Heracles?
Yeah, so most of the craters, most of the features that we see on the moon were formed due to impacts. In fact, there was actually some controversy or not controversy, that's putting it in the wrong light. There was vigorous scientific debate for a long time whether they were volcanic in nature, which there is some evidence of volcanism. In fact, in LRO images in particular, you can see lava tubes and other feet, and there are some volcanic features, mountains, but most of the craters that you see here are impacts from space rocks, asteroids, comets, various things. You know, the moon does not have an atmosphere, so therefore it has no wind. There's no weather, there's no rain, there's no running water, and it doesn't have plate tectonics, which, you know, over geologically significant periods of time, resurface the planet. The moon, the Earth has those things, the moon does not. Therefore, the moon shows these events from millions and billions of years ago and hundreds of thousands of years ago. It's like a record, if you will, a historical record. In fact, there's a whole science to even dating the craters. So does that answer?
I would say so. I don't know if anyone would benefit from this. I kind of think it's an interesting way to compare, you know, how craters actually get that kind of perfect round shape to anything else that we may see online. I have a video here. It's just a YouTube link. It's kind of a slow motion video of, if you've ever seen one of those drops of water breaking the surface tension. It actually, the creation of the ripples and kind of the springing back up of the water looks a lot like the end result of these craters. I don't know. Shall we?
Sure. I'll stop sharing.
Let me double check, make sure I can actually share here. I've just got it on a loop. Here we go. And of course, this is any one of those cool slow motion videos. But what you'll see, once I can actually get to my meeting screen. So what you'll see, forgive me, I'm seeing some difficulty here.
While you're breaking that out, all I'm going to say is that if you live in Western New York right now, go outside and look up, because it is beautiful. It is clear. There's some.
Well, after the presentation.
Yeah. Or bring your phone outside.
Outside.
Bring your phone
Hi,
outside.
everybody.
How am I looking on here? Well, you can see the rest of my pages, but that's okay. So what you'll actually see, and you can actually kind of see this a lot on kind of on the moon. I've got this, just kind of keeping going.
There's the rebound.
There's your rebound. So I get asked this question sometimes if I'm you know, teaching usually kids, but it's really interesting to be able to compare this. Imagine you've got something impacting, creating your crater that's moving at thousands of miles an hour. Once it eventually hits that stationary object, it's going to be going so fast that and if you'll see right here, it almost immediately, just by shock, melts a lot of the rock around it. And what you'll actually see sometimes is some of that shock instantly melted rock, it will spring back up like you would see right here. And that's why you'll see, especially, I don't know, Adam, if you want to maybe find, there are several large craters on the moon that have what looks like a small mountain in the middle of them. And it's almost like that that splashback of molten rock just being caused by the shock of the impact that's being created. I was always wondering as a student why there were every once in a while mountains down there. So it's pretty interesting to kind of see that just the extreme stress that's being put on whatever is being impacted, being smashed into to form a crater, is actually it's actually kind of creating a liquid effect. I don't know. It was something I always appreciated. I'll stop sharing now.
Holly, I'll put a Barlow lens in, which will zoom in a little bit more, and we'll see if we can find one of those peaks.
And it looks like Jim Maroney's got a view of the moon. I don't know if he wants to share his screen.
Yeah.
Good idea.
Let me text him. I don't know if his audio is working.
So right here, I've got one. It's on the southern side of the moon here, I guess you'd want to call it. You can kind of make it out right where my mouse is here.
That's a very nice image, Jim. Very nice image.
Wow. Very good.
That's beautiful.
I say, I hate to be a pest. Could you put the south end up so it matches my charts?
I'm liking the NASA gear, guys. Should I go get mine?
Yeah, there's my moon.
Awesome. Actually, if you look at the north end of the moon, there's a pair of craters there by the edge on the Terminator, near the top. Crater 21 and 137. The one that's closer to the edge should be Atlas, and the other one is Atlas and Hercules. All right. So we got it back on the moon for anybody?
Hang on.
Not a problem.
I can put it back on the moon.
I can identify at least a couple of the craters near the north end. And they also look like they have raised centers.
You want south up?
Or
you want north
it's
up?
more convenient because that's how they print the charts.
Okay, I'll put south up. So
Why make life difficult? Because then I got to read the chart upside down and I can't read the words upside down. So makes it difficult.
You can't.
No, I'm not that good. I'm lucky I have a chart. I don't look at the moon. Moon comes out, I go home.
Well, that's because you like imaging deep sky, Dan. It looks like we had a question about the sky becoming clearer in this whole quarantine thing. And, you know, there's definitely less pollution happening. And in turn, the air is a bit clearer for seeing and viewing and imaging and such. But also there's less light. And light is a pollution that we have to deal with. I sit in a backyard where there's light constantly, and it's very difficult for me to image deep sky objects from my backyard. I have to do lots of filters and take lots of time, and it takes extra time from a dark sky site. But because of this whole thing going on, there is less light pollution as well, less noise. And so it makes it a little bit better for stargazing, even going out and taking a look up. So like Mike Humphrey said and Ernie said, tonight's skies are actually very clear, especially for Western New York. So go outside and look up.
All right. I'm going to share my view of the moon. If it's still, why is it not? Hang on. I'm gonna stop sharing. I took my I gotta turn my mount back on.
Well, here,
That's all right.
I'll
I
share
put
my view.
I got the live view of the moon with my client.
Here you go. I'll put that in full screen. Can you see that?
Yeah, you get north end almost up. Could you south end up be handy?
There we go.
You rotate that camera like so it's upside down.
I can do anything we want.
That's a spirit I like to hear.
I gotta tell you guys, this
That's
contrast is just looking
They
so.
win.
okay. Now I have to sit there and ask you a question. Do you have a diagonal in your system?
No, it's actually going straight through.
You're going straight through.
Yeah, but don't forget, this is the cat, so I got 2 mirrors.
It doesn't matter. 2 mirrors will bring things back to normal. You have north end up right now, right? You want south end up. Ah, much better. Keep going, keep going, keep going, keep going. A little more.
Hang on.
You're getting there. Yeah, for those that are listening, all the charts are printed upside down, so keep going. You can rotate it like another 45 degrees. Oh, right there is perfect.
Oh, okay, let me focus.
That's good enough. Get her in a focus and yeah, I've been looking. There's supposed to occult a couple of stars, but the skies aren't dark enough for us to see it. We'll have to pay attention to that. Okay, if you get towards the north end of the moon, down the bottom there, and reduce the exposure a tad, there's a pair of craters. There's Atlas and Hercules. Pop up my screen
Once
so I
you
can
get
see
there,
better.
Mike, you can reduce that gain just a little bit.
Yeah.
Yeah, right now they're overexposed, so.
Do we have time to answer another question while you guys get
Sure.
settled? All right. So I got a question from, let me just double check. His name's Mark. He asked, with the rate of the moon, kind of the moon's orbit actually getting slightly further away from Earth, and actually slowing down eventually. How long is it going to take for that effect on Earth to actually have some sort of effect on things like us, nocturnal animals, anybody's circadian rhythms, our sleep patterns? The short answer is it's going to take a really long time for anything like that to change. Basically, the orbit of the moon, basically as the moon orbits Earth, it is taking a little bit of that movement, that kinetic energy from the orbit of the Earth itself, which actually means that Earth's days are getting longer the longer that the moon orbits us. The thing is, though, that in about 100 years or so, let's call it a 100-year time span, the day here on Earth only extends about 14 milliseconds. So it will be probably millions of years before we see anything affecting us more than, a few seconds or a few minutes per year. I'm doing a little bit more research. I'm kind of trying to figure out how long it'll take to get from a 24-hour day to a 25-hour day. So the short answer is it is an effect that the moon has on us down here on Earth, but it's not anything that humankind or even, any animals or plants for that matter are going to be affected by, in our respective lifetimes. So hopefully that helps. How are we doing on our moonshots?
Nothing like electric focus.
That's looking better.
Looking a lot better. And I see our pair of craters that I'm looking for too.
And just looking at Sky Safari, it'll be hundreds of millions of years from now before we end up being tidally locked to the moon. So
you're saying we don't have to worry about it?
No, Not us.
Well, I don't plan on being around for it. Let's put it that way.
Now, with it having such a small effect on our length of day or anything with our rhythms, is this going to change at all the power of our tides? You know, the moon's gravity kind of causing the tides in the ocean. Is that going to change anything having to do with it? I would assume no.
It should affect the tides. Once the moon gets tightly locked, you still have the tides due to the sun. So I don't know. We need someone who can do the tidal calculations, and I'm not one of those people. But right now, you have the sun and the moon that give you the tides. I believe the moon has the greatest influence. The sun has a little less influence. So once you eliminate the moon, because the moon's going to have a bulge, or the tide is always going to be facing the moon. And since the moon and the earth are going to be locked together, that tide is always going to be in that one spot on earth. But you still have the problem that the sun is still tidally pulling on everything. So there still will be tides, I would think, just they wouldn't be as high. Well, let's see, if you want, I can try to see if I can pop my screen on there.
Do you mind if I share mine?
No, not at all.
Go for it.
While somebody's getting there, I just got to find the right screen.
Yeah, that's the problem, isn't it?
Yeah, it's like, where is Zoom?
Yes. There you go. Oh,
So I got
perfect.
south. You wanted south up.
Yeah, south is up is perfect. Get me to the north end of the moon, though.
Okay.
See, I cheat. Mine's all motor driven. I cheat even further because I'm using my DSLR. I don't have to move the mount. Okay, oh, right, all right about there. Okay, the two craters that look like two little eyeballs. Let's see here. You got your mouse? Slide your mouse up to the moon. There's a pair of craters.
Yeah, Atlas and
Right.
Hercules.
Right, those are Atlas and Hercules. I believe Atlas is to the left. See, that was 27. Hold on. You know which one's which? 21, the one on the left is Atlas. The one on the right's Hercules. That means then that the next crater down below them, there's a big washed out crater on the edge. Keep coming lower to the left right there. That one right there. Let's see, that one right there is number 95.
How's my focus?
Not bad. 95.
Good.
Endymion, I guess. Endymion, Endymion.
I went too far. Trying to do this by hand.
Yeah, it's difficult. Hold it right there for a second. That's a Merocrisium, the C. That's the C showing right there. I think that's Merocrisium.
Yep. This is
Oh, no,
This
that's
is-
not true. That's up too high. I think.
no.
No, that's Merocrisium.
Yeah.
And then there's a pair of craters near the bottom. There's a nice shadow in those craters, isn't there? That dark crater, if you go up inside the mirror.
Oh, right here.
Yeah, that one right there. That's number 223. Find that in a minute. 223. That's Peard, P-I-E-A-R-D. And then there's that interesting one that's below that one. Looks like a little slice in there. You got some pretty nice resolution there. Yeah, that one right there. My guess is that's 218.
There's Addie. Hi, Addie.
It's Geminus. About the down near the bottom, you got a nice bright crater, a dark crater off to the right. That one right there. Okay, that one's labeled 182. 182. Oh yeah, Microbus, Macrobus, Macrobus.
We've got a guest. Hi, Addie. Adam's little girl, young little astronomer, young little scientist.
Excellent.
Go ahead. Sorry.
Right. Oh, you can't wander up northeast, can you?
You want me to head up?
Sure.
Okay. Do you want north or south?
Be the south. Oh, hold on. Okay. There's a nice pair of craters there. Now you can see the craters with the humps in the center. If you look at them, most of them, there's a couple of prominent ones right there in the terminator, right there. Hold it, hold it, hold it. Right there next to the terminator, near the bottom of your screen, there's a nice crater with a hump in the center. As a matter of fact, if you look at a good deal of those craters, all have humps in the center once he stops moving things around.
I know which one you're talking about, Dan.
Here, I'll bring my mouse. I just didn't want to let go of the telescope and have it swing back.
Gotcha.
Right here.
There's one there. Yep. And if you head up actually, there's a whole pile of them there with the humps in the center.
Yeah.
But it's not an uncommon feature.
Yeah, right here, and there's a nice one here.
Yeah. The interesting part of it that I remember from Cliff Stoll's talk was that the craters are all spherical, well, all round, circular. And they're circular. It doesn't matter which way the meteor impacted. If it with a nice glancing impact, straight on impact, unless it danced off it, the impact, the amount of energy that was created and released then is more like an explosion. It's not like a push. So when it impacts the moon, the amount of elongation caused by the moving of the meteor when it hits is actually quite a bit smaller than the amount of the explosion. So the explosion wins out and makes all the craters round.
They actually use some of the nuclear test sites out in like New Mexico, out west, for some of the lunar training.
Well, there's your ingenuity.
So, you got any good craters for us here?
Well, why don't you poke a big one? Let's see. We got one on the Terminator.
Yeah, right here.
Right there with that interesting looking doodad next to it. The peak in the center, that's 224. Oh yeah, I'll pronounce this one there. Piccolomini, I guess. Piccolomini. That's an interesting thing that you got just to the right of it. Your arrow is sitting on top of it.
This feature.
Yeah. That's some
Also
sort of
notice
wall.
these 3 craters too. Boom, 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 right on top of each other.
Yeah.
What's this big crater here with?
All the stuff in it?
Yeah.
Good question. Let me see if I can figure it out. Can't really tell. It's you get the libation on the moon, so I'm not exactly sure where the edges are. There's a pair there.
Jansen. Is that Jansen?
246. I don't know. I'll tell you that. I don't know.
And this is a valley here, right?
Oh, a second. I'll tell you. I get.
Valley's Rada. How loud is the dog coming through?
Not Ed?
My dog's
I'll,
off.
I'll mute myself.
While you guys are finding these craters, we have a couple of questions about the diameters of Atlas and of Hercules. So those are pretty quick. So Atlas is, well, let's see, it's about 87 kilometers across. And we'll see actually which one is larger. I believe you guys said it was Hercules.
It's hard to say. I assume that the Atlas is the larger of the two.
Oh, actually, Atlas is the larger one. Hercules is only 69 kilometers across.
Yeah, I'm starting to troll for stars the moon's going to cult. I don't see any yet.
We're starting to get clouds encroaching from the west. They're coming up to meet, and they're coming up to meet the moon and Venus. And if you were to look at the moon right now, you can actually see what we call earth shine. So you can see the illuminated portion of the moon from the sunlight, and then the dark portion of the moon. You can actually make that out. You can make out the full disk. And that is earthshine. That is the light from sunlight reflected off of Earth, reflecting off the moon.
Yeah, actually, what's pretty neat, if you get to the south end of the moon, you can see the lunar mountains being illuminated. You get these little points of light that sit out in the middle of nowhere. There we go. You can see there on the tip of the southern portion of the moon, you can see the bright spots. Those are actually mountain tips.
So is it getting dark enough to grab anything deep?
No.
Or it's still too light?
Not yet. I just got Polaris showing up in my polar alignment scope, so I'm going to try to polar align.
So here's an interesting quiz question. Anybody who's been paying attention, when you're looking at Earthshine, how long does it take that light to reflect to the Earth, from the Earth to the moon and then back?
You want us to do math?
It's exactly twice the time I told you.
Rusty right now. It's math.
2.6 seconds.
2.6 seconds. Yeah, you looked it up.
No.
Yeah, we just
1.3.
know. Yes, they say 2.6 seconds.
How many times does it take a photon of light to go around the Earth in 1 second? Or how many times does a photon of light go around the Earth in 1 second?
Now, that's math.
7.5 times.
Well, if you guys want to hear a little bit more about the importance of math, we have another question here from Edward. He asked, we ourselves on Earth are traveling around the sun with the moon orbiting us, kind of in turn. So we're moving at, tens of thousands of miles an hour through space in our track around the sun. So our question was, how were the Apollo missions, those of us who were actually like in the command module and on the moon itself, how were they not left behind when they kind of circled back to go back home? The answer to that, I mean, I'm sure you guys may be able to say it a little bit more eloquently. It's just math. Before launching anything, scientists at NASA were kind of accounting for how much time is going to pass between, lifting off from Earth and coming back down. And you actually had to kind of program these relatively simple machines to get back not to where Earth was on the day that you lifted off, but where it would be however many days later. All of these things, you know, luckily, and you know, we're living in a very nice and easy time right now where there are lots of scientific models and computerized, you know, imagery that we can use to kind of visualize these things. Everyone had to do this by hand back then on very rudimentary computers and, you know, pencil and paper. Everybody did these calculations. They were sure that once the Apollo astronauts got to the moon, that the moon was in the right spot for them to slow down and eventually land, and that once they lifted back up off the moon, you know, to kind of head back home, that they would be heading back to a place where the Earth would be. Because if they didn't, well, we wouldn't have a whole lot of very successful Apollo missions. Almost everything that I think we have to that has to do with tracking and seeing the future as far as any of these things that are orbiting us, orbiting the sun, or just, you know, containing, let's say, people or our instruments. It all has to be modeled beforehand. There's quite literally very many moving parts.
Yeah, and the other piece of it is the moon and the Earth are orbiting around the sun together, and when you launch into space, you're changing your velocity relative to Earth and relative to other bodies. The specific term that's used is delta V. And so, you know, when astronauts in the space station, you know, they're moving at about 17,000 miles per hour. And if they were to increase their speed, they would raise their orbit. In fact, paradoxically, it's really hard to get to the sun. It's easier to get to the outer solar system than it is to get to the sun, because you have to lose all of the speed that you have being on Earth. So you have to have delta V in the opposite direction to slow yourself down to get to the sun. I believe, if it's not already, at some point, the Parker Solar Probe is going to be like the fastest man-made object out there.
Yes.
Yeah, it will.
Right now, it's the New Horizons spacecraft, the one that passed by Pluto, and eventually, as the Parker Solar Probe gets closer and kind of gets into position, that's going to be the fastest.
Hey, can you guys hear me yet?
Earth, I'm sorry. We on Earth, we're rotating around the sun somewhere around 67,000 miles per hour. And like Ernie was saying, if you just want to orbit Earth, right, you got to go 17,000 miles per hour faster. But you have to take off all that energy to get down to an appropriate speed to fall back down to the sun, essentially.
How are we doing on viewers, by the way?
Can you guys hear me yet?
Is there anybody still on?
Can I be heard yet?
Hi, Tim. We can hear you. And
hey, look at that! I finally found my microphone.
We have 50 viewers right now.
I don't know if somebody's got a better telescope than I probably. But I do see a star under the chain of 3 mountain peaks on that lower hemisphere. If somebody wants to slow down a little bit and check that out, there's one there.
Okay.
What are you looking at?
I tried to answer that 15 minutes ago, but nobody could hear me. Dan asked that question.
Here, let me give you, I am looking at Capella right now. See if I can get back to there. And I'll share my screen.
All right, I'll stop sharing. Hang on. Oh, come on, don't move. There we go.
Well, I can see the Earth shine, but I can't see anything within one lunar diameter away from the moon. There's nothing close enough for it to. Real quick.
Why is it not?
There's something there.
There we go.
Oh, was that the moon?
Yes, it's just a little out of focus right now.
There you go, Capella. So I just pulled that one up. And right now I don't have a lot of trivia about it. Just think it's pretty cool.
Whoa. What did they do?
How you doing?
They're hearing you, Emily.
Hi,
My
Emily.
daughter is here too.
Oh no, that's cool.
You can ask questions.
What?
She didn't. I'm focusing on my my 8-inch here, my need. So she was trying to figure out what you did, and of course I can't see you, so I don't know what you guys did over
I
there.
have no idea what's happening on the screen.
Well, I'm trying to focus the moon for you. There you go.
So you're saying there's a star, a moon melting a star right now?
Yeah, it's if you.
Yeah, I'm
My
starting to get some
orientation-
stars now. They're coming out. So this is really
Yeah, it's.
cool. Oh,
Let me raise the gain.
Let's see. I'm trying to
hey, I'm gonna come out
get
of
a bearing
screen
here. I
share.
got to walk away from my sticks so I can see what's going on up here. Yeah, it looks like it's in Taurus, whatever it is.
That's far away from the moon.
Well, not the well, at the end of it, but okay.
Illuminated north, south.
Let's see. Gemini. We did have a Starlink flyby not too long ago, by the way. Eric Briggs had chimed in with that, but I don't know if he's on this one or if he's just on the Facebook Live.
Oh, I see some stars. Okay. Yeah, there is a star near the edge of the moon.
Yep, that's one.
Where is
There
it?
you got it.
Didn't find it.
So as you guys find this, I can answer a really quick question. Megan asked how heavy a 200-pound person would be on the moon. So, of course, if anybody has ever seen the footage of the Apollo astronauts, you'll kind of see these guys in these giant spacesuits sort of hopping around. The moon being so much smaller, it does have a lot less gravity than Earth does. And it's about the transition or the transfer, the exchange rate, I should say, is about 1/6. So someone who is about 200 pounds on Earth, you know, not counting spacesuit, any of that stuff, would be somewhere around like 30 to 35 pounds or so on the moon.
Okay, I see it.
Hey Ernie, can you hear me now?
Yeah, can you? Who is this? Jim?
Jim. Yeah, I
Hey,
found
Jim.
the microphone to work after 3 hours. Don't buy an Alienware.
Well, welcome.
Oh, look, I have another moon behind me. Oh, yeah, it's my street light.
You got anything?
Yeah, actually, we have a star that's going to wink behind the moon pretty quick now.
Oh, I got Starlink. Starlink is passing overhead in the south right now. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right over the moon, right between Gemini and the moon. 17, 18, 19.
That is
I hate
amazing.
you, Elon Musk.
Yeah, well, there you have it.
It's amazing, but it's getting very annoying.
Yeah,
It is getting very annoying.
For those of us who aren't out there all that often, most astronomers are really kind kind of getting their jimmies rustled over these Starlink satellites, because imagine trying to take a long exposure photo and having all these satellites photobomb and streak past your beautiful stars that you're trying to capture.
Yeah, it's seen too many ruined photographs.
It was nice when it was just the iridium flares, because those we could handle.
Hurry up.
Has there been any data released about the one satellite, the one Starlink that was all blacked out to help mitigate this problem?
It was marginally darker.
Marginally.
Oh,
You'd have to coat the thing in Fanta black.
so in my finder scope, I can see the star you're talking about. It's still pretty far away from the moon, if that's the right star. Am I looking at the right star?
Ernie, you're looking rather sinister there.
What's that? I didn't hear that.
So that is a second Starlink.
When's it coming?
No, the one we just saw was the second one. Eric, it had the first one about now. I don't know if that particular array is coming back or not, but I would think it would come back again in about an hour and a half.
I'm gonna go to Venus. Before I lose it.
Venus was a nice crossing tonight.
Yeah, we had it earlier. Somebody had, Dan had it.
Yeah, I can get it back again if you want, but
Okay.
That'd be nice.
actually I got an interesting shot of the moon here if you want to take a look at it. Let me pop it up here and see if I can find how to share. Come on, how do we do that? Okay. See if I can share this with you. Let's see here. This is with my finder. This is the auto guider camera. You make out the star right here. It'll be occulted by the moon very shortly. And we'll have this guy, he'll entertain us.
Yep.
And a
Those are the
little
ones
later
I
in
was
the
looking
evening, this guy may just graze across the top. We'll see. But this guy's going to disappear in another 5 minutes. Maybe the little camera does. Yep. A little too much exposure. Back off and again. There we go. You can still barely make it out right there. There we go. Yeah, until someone gets themselves on Venus there, we'll see if we can watch that thing disappear. I don't know how much longer it's going to take before it goes, but it won't be that long. Still there.
Yeah, I'm still there.
Gonna wink out any second now. Oh, there it went. Now we got to see one occultation. I don't know what those little, I don't know if you guys are seeing it, but I'm getting little streaks going from left to right. I don't know if it's a camera artifact or what, or if that's our Starlink satellites. Yep. Oh, you saw that one just appear on the screen there. I don't think they move that fast, so probably some sort of issues with the camera. I'll stop my share.
Do we have time for another question?
Absolutely.
All right, I'd be happy to answer another. Let's see. Back a little bit. I'm finding one that I really have wanted to answer. I just gotta locate it. Oh, here we go. So the question is by Ronald, and it kind of concerns the movement of Earth kind of around on its axis. So a lot of us learned, in grade school that, the Earth is kind of tilted on an axis about 23 degrees or so, 23 and a half. Now, the question was, what is kind of keeping us from wobbling kind of like further, kind of having our axis tip further than maybe 23 and a half degrees to 30, 40, 50, or 90 degrees, where maybe this would be our North Pole and this our South Pole. Luckily, we have the moon kind of to thank for a little bit of this stability. With the moon orbiting in a relatively stable, predictable orbit around us, its gravity is kind of whipping us into shape. It's not really allowing us to kind of turn our tilt on our axis to be what we call more oblique, more on its side. But one planet that actually does kind of suffer from this, or has suffered from it in the past, is Mars. So Mars does have two moons. They're called Deimos and Phobos, and they kind of look like little lumpy space potatoes because they're very small, and we actually think that they are captured asteroids. They actually kind of got roped into Mars's gravity, and now they go around Mars. They are much smaller than the moon, and they don't really contribute a lot of gravitational pull. So without the kind of gravitational influence of a nice big, relatively large moon like ours, in the past, the tilt of Mars's orbit has gone really, really crazy. This happens over, tens of millions of years in some cases, but there's actually evidence in the rocks on Mars that Mars's orbit, which is not too far off from ours, was actually turned so that more of Mars's poles, either its North Pole or its South Pole, depending on where it was in its path around the sun, were a lot more extremely tilted either towards or away from the sun. And that would create really, really extreme seasons for us. Luckily, we don't really have to deal with that here, thanks to our moon kind of keeping us in shape. But it actually on Mars caused the ice caps on the North and South Poles, similar to what we have here on Earth, to kind of move. Because eventually, as Mars's axis tipped further and further away, the poles were not the coldest places on the planet anymore, and they were not the most hospitable to ice. So it actually ended up being that a lot of the ice that was on the North Pole or the South Pole of Mars kind of migrated and got a lot closer to what is actually the equator of the planet, right in the middle. So it does happen, just not to us. And we are very lucky because of that.
We got a fuzzy Venus here. I don't know if you guys can still hear me,
I hear you.
but I got the 3x Barlow, so it moves through the field of view pretty quick. Trying to get it to stabilize in the center somewhere, but doesn't want to. I'll just try to hold it.
So while you're getting that, I saw Jennifer O'Donnell had a question about the OR2 asteroid that's projected to come within 16 miles the distance between Earth and the Moon. I think April 29th is the date. She wanted to know if it would be visible from Earth. So we measure stars by their magnitude, visible to people without the assistance of a telescope or with a telescope. It doesn't look like it would be for me. The absolute magnitude will be approximately 15.8, so that's going to be a fairly dim magnitude, correct?
I thought the visual magnitude was supposed to be like 10.5.
Okay, this is from Wikipedia, so it could be a little dated material.
Well, it may be. It's going to vary in brightness depending on where it's at. It's orbit and where we are. We might be able to go looking for it tonight. I was just thinking about that. It's starting to get reasonably dark. I just took an image of M44, which doesn't look very good, but I was just going to hook up the sky to my mount and see if I can go look for the asteroid. It'll take me more than a few minutes.
You let me know. I'm on. Jim, you still there? What about Tim?
I just had a little accident cleaning up.
I can show you M44 if you want. Guys want, not that it looks anything special.
Okay.
Oh, that sounds. Let me just get that on over on that screen so I can find it. Actually, I think I just have to share a screen and pick it then. There we go. Screen 2. That works. Okay, let me just get rid of what I got on screen 2 over here. 1 second.
So while you're doing that, you're showing that that's M44, the Beehive cluster.
Correct.
Which is in a very dim constellation called Cancer, the Crab.
Yeah, that's just a collection of stars right here. Not all that impressive. This is more than a half a degree. And the moon is about that big. So about a degree in diameter. Not well centered, but that's all right. I was going to see if I can find the asteroid. While you guys keep talking, I'll start looking for it.
I'm going to pull up Stellarium here. I got Stellarium up.
Actually, does anybody know the magnitude of those stars? That'll tell us whether we can find that asteroid or not.
It's which stars?
The stars in the M44. Hang on a second. Let's pop it up here. We can do this. We have the technology, maybe. No, it'll let me do it. Fine. Okay, there we go. Find. Yeah, it's 10 stars I'm picking up now are 10.3 meg. So we ought to easily pick up 10.5 meg if that's what indeed it is. So I'll start looking for it. I'll stop the screen share and I'll let you know when I find it, if I can find it. It's not in the trees or something stupid. All right.
I'm going to share my screen so that lovely open cluster, which are a collection of stars that were recently born. Sorry, wrong screen. Recently born together, astronomically recently anyways, is here in this constellation Cancer. So here we have in the west, above the moon and Venus, we have in the southwest, we have Castor and Pollux, which are part of the Gemini constellation. And we have almost straight overhead, the bright star Regulus, which is in the constellation Leo. And if you kind of go from Pollux to Regulus, right in the middle, right here is that deep space object. And I'm going to turn it on. computer's really slow.
Yeah, it doesn't help to be zooming and doing all the stuff.
So I'll zoom. Oh, going the wrong way. There we go. I'll zoom in. And you can see there's where that cluster that Dan just had up right here, the beehive cluster. And if you own a pair of binoculars, it's you can find Regulus. So look almost now straight up ahead and look for the question mark asterism, and kind of at the bottom of that question mark or just below it, there's a very bright star. That's Regulus, the heart of the lion. And then over towards the west, you can see Castor and Pollux together. They almost look like two eyes. And Pollux is the one a little bit closer south. Draw a line between the two of them, and almost in the middle, you should be able to find this object, and it's very, very pretty in binoculars. So how we doing, by the way? It's like 9:20. I see like Dennis and Mike are gone, right?
No, I'm still here. It's 9:18.
Oh, you people must. You doing okay, Phil?
You know, guys, I think our viewership is a little bit down. It's getting a little bit late. I think we should run a last call for anybody who has a really good, show to tell.
All right, let me take a quick look here. I'm going to stop sharing.
Yeah, I'm all right, but I think we're, our audience is getting smaller and it's getting pretty late, so.
Yeah. Let me take one quick look at the moon. It's starting to get fuzzy over there.
So we know that the audience is going away, but this is when amateur astronomers get up. And so while everybody was showing you everything, I was polar aligning. I'll do a quick share while Ernie's looking to do. So this is called polar alignment. And let me just pull up my PoleMaster app here. And so you can see right here on the screen, right now, I am now finally polar aligned. So now I can actually track on objects and hold them in view for a long period of time to take deep sky images. So I'm just going to stop that share. But it took that 20 minutes because, well, I didn't have my computer next to my telescope and I had to run in and out.
Wow, the life of an astronomer. All right, everybody. Let's see. I'm going to do one more sweep for any last few questions. I think we got most questions, but for those of you who have not had yours answered, I can try my very best to store them, answer them later on.
All right.
Do we have a lot of questions out there or just a couple left over?
We got most of them.
Oh, cool.
Oh, so here's a pretty interesting question about precession. I'm not an expert in this stuff, so hopefully those of you with me can help me out. So this is another question by Mark. When was the last time, with the precession of Earth kind of relative to the stars in the celestial sphere, when was it the same as it was now? Kind of with the basis of this question being right now, our North Star is sitting pretty much right over the North Pole of the Earth, which is very, very useful for those of us in the Northern Hemisphere. But because Earth is wiggling a little bit on that 23.5-degree axis, that has not always been the case. Has there been a point in, at least recorded history where Polaris has been our North Star kind of before this last round of Earth teetering, or was that maybe a little bit too further back?
Yeah, no, I can take that. It's a 26,000 year cycle.
Right.
So it would have been 26,000 years ago that we would have been right where we are now.
Well,
So it's
more or
possible
less.
humans,
Yeah,
saw
give or
Polaris.
take a few thousand.
No,
So
give or
it's
take a few
possible
degrees.
people saw Polaris as the North Star, but they may not have had the technology to write it down or talk about it.
Right. Or the awareness, we don't know,
Yeah. Well, see,
how
not
aware
only-
we've been for how long.
Right. Well, see, not only does the Earth axis precess, but the Earth stands up straighter and falls down farther. So you have to take that into account as well. I forget that that's another cycle in there. So you have to get the two of them to match up for it to be exactly the same. But essentially, it's every 26,000 years. But you do have to worry about the fact that the Earth's tilt isn't the same either. And
There's a lot
that
of,
wobbles up and
optics
down.
to play there.
Right. And do you know if the sun is precessing?
Yeah, there you go.
Because that would affect our precession as well. So there's a lot of layers into that. But essentially, the basic answer is 26,000 years ago.
And about 26,000 years from now.
From now, exactly. Or 52.
Right.
Or 78. Or any multiple of 26.
Yeah.
Well, it oscillates on a 41,000 year cycle between 22.1 and 24.5 degrees.
Okay. There's your 3 degree shift.
Well, yeah, 2.5 degree about, somewhere in there. Close enough for horseshoes and hand grenades.
My moon's getting fuzzy.
Uh-oh, clouds.
Better give it a shave.
Yeah,
which is something I have not done in about 4 weeks.
All right. So
But you couldn't see that.
Just about all questions answered. The last one that I just saw, the most recent one being, are we excited for the James Webb Space Telescope? Which I'm sure that's an easy one.
Yes.
Yeah.
Scared and excited.
I've got a relative who works kind of in space and telescopes, and I was so jealous of him. Last summer he showed me he took a mirror selfie in the James Webb Space Telescope mirror. And I wish I could do that myself, but it's probably getting packed up or tested for getting packed up now. So there's one more thing to look forward to.
It's going to be a unique project, not only by the scope of how it unfolds itself and creates its own solar shield so it can maintain its dark sky, but also to where it is in orbit, being at a Lagrange point, a balance between the Earth and the Moon.
It's going to be very unique. I'm not sure we could even talk about what kind of stuff it's going to bring us. It's going to be brand new.
It'd be hard to service though. That's the only problem.
Oh, I'm sure. Let's be sure it has
mistakes.
Glasses. Oh, Lord.
Dennis, you got anything? You got anything in the camera?
I didn't get anything in the camera yet because now I have to go, now that I'm polar aligned, I have to go to an object. And so you got to give me a minute to do that. Takes a little bit of going back and forth here, sorry. So if we need to wrap it up, that's okay.
Well, and for anybody still watching, while we do kind of fiddle around with this stuff, the good thing about all of us kind of being kind of queued up to our own computers is that even after we end the stream, if it turns out the sky decides to clear up and everybody is, still out there with their scopes, we can record some footage and show you next time we do this.
And also, too, this is a great opportunity for people who are still watching. Please reach out to us if you have questions for our next opportunity that we get to have everyone together here.
It'll be a little warmer.
Hopefully.
And if any of you are watching this for the first time, this is kind of our first official session. We did a little bit of a test one the other day with probably about the same degree of success. And, the skies were not really cooperating, but, the show does go on here. We just, we'll bring you different things to talk about and learn about.
Tomorrow night, you got another opportunity for Starlink at about 8:46. Be a 40-degree maximum altitude southwest.
What's the forecast?
That I don't have in front of me. I got to switch apps.
100% clouds.
So you won't have a.
Starlink will not affect my night view tomorrow night.
Where's our next hole? Where's our next hole?
Oh, that's kind of why we jumped.
I'm looking here.
Friday the 1st, around 2 to 3 o'clock. You know, it's
At
it's
2
about-
a.m.
Yeah, 2 a.m. to about 3 a.m. Maybe.
Yeah,
4
we need
a.m.
about an 8 to. Oh, there you go. Sunday the 3rd. I got a little bit on Sunday the 3rd. Let me check that one. I'll check that Starlink log here and see if I can get over there, give you an idea of when you can view it again.
So what link are you, or what website are you guys using to track Starlink progression?
I am on Heavens Dash Above.
Heavens above
Okay.
for that, I think.
Let's see, April 2020 Starlink 6.
Hey, Jay.
Yeah, it looks like the Epic runs out here on the 28th. Why don't they have a past 20th, or am I just like really slow here? 30.
I see Jay's joined us.
And yeah, Eric Briggs just pointed out the nights aren't getting any longer either, so we're not going to have much opportunity with Starlink as June rolls around on us. Let's see, my search is turning up blank for the first week of May. So they are going below our visible band here. So that is it. Well, it's Starlink, yeah, Starlink 6. So that was it. Barring clouds, sneak peek tomorrow night if you get a break.
How are you doing, Dennis?
Trying to buy you some time, Dennis.
It's called turning on the bright lights and don't trip over the cord that you have out to your camera. So I think you don't wait on me. I apologize.
That's okay. I think now might actually be a good time to say goodnight. But hey, this was extremely successful. We wanted to maybe get 45 to 60 minutes of content, and thanks to your guys' questions and all the experts that we have online right here, we've made this, a very packed night. So thank you for those of us who
Thank you.
participated. Thank you for those of us who watched and who are watching. I know personally, my dad has been telling everybody about this. So, hello, Cohen clan. If anybody else has anything to say, now would be the time.
Thanks everybody for joining. Really appreciate it. It's a lot of fun too.
Yeah, this is well done. Thank you.
All right, guys, stay tuned on any of your social media channels and communication channels where you heard about this stream before. We are going to find another time to do another round of this, and be sure to come and watch us again. Come with questions.
That's good.
To everybody,
If anybody wants to stay online, I'll see if I can find that asteroid. I just have to go change the battery on my camera.
Yeah, and you want to start a new Zoom?
Thanks, everyone.